look at the article or the study guide, okay, to open the study guide. So if you look at the study guide that is posted there, so you have here radiochemical methods, and then this is just a review of what we call nuclear chemistry from your Gen Chem. Okay. So I have a short discussion on that. And then I think there are some problems here. If you put at the links, there are some problems, sample problems with solution. And although I'm going to also discuss some of this. And then here, they have some discussion on the method that we have. So I'm just going to give you a very brief one. And I think aside from the nuclear chem review, I never discussed any radiochemical methods in my life, although I have experience using some of them. Okay, so these are some of the sample problems that you have there. So if ever I still have time for problems, that's where I'm going to, similar to the question here, but I'm not sure because you're not the only one who are in the stretch. Okay. Right now, I'm also on stretch here. So you'll be lucky if the quiz for module 6 will be available tomorrow. But I'll try my best to make it available in the problem set 6. And as I promised, problem set 7 and 8, most likely, if ever may lumabas katulad nito, at least a 7. If not, then we'll just have the quiz. Okay. And then the study guide 8, I think they also have a very good presentation there of the laser diffraction analysis and the dynamic light scattering. And it's usually more than 1 hour. Okay. These are new methods. So usually the one who presented this are companies selling this type of instrument. So I leave it up to you, okay, on the resources, and also this what we call photo sedimentation. Okay. And if ever I have problems set here, I think I will just ask this guide question here, but that is assuming we still have time, because I know you're also in the home stretch for the different courses that you have at this time. So parang hell week na, okay? Both the students and the faculty. So let's start. Just need to share. So this is what we call the radiochemical methods. And I think the review that I have here is what we call nuclear chemistry. So based on the nuclear chemistry, it involves usually the nucleus of the atom, because most of the chemical reactions that you have discussed in your general chemistry are what we call involves the electron. But when you're talking about nuclear chemistry, it involves the nucleus. And they found out that the reaction in the nucleus is more energetic compared to the one that is produced where electron is involved. Okay, so atoms that has the same number of protons but different number of neutrons, anong tawag natin doon? Kasi yung parang nagre-review lang tayo eh. Okay, so yun yung tinatawag na isotopes. Atoms that has the same number of protons but different numbers of neutrons, or same atoms with different atomic mass. So if you're going to review, meron kayong tinatawag na atomic number tsaka mass number. Okay, atomic number is the number of protons in the nucleus. Mass number is the number of mass plus the neutrons. And usually that's also equals to the atomic number plus the number of the neutron. And whenever you describe this, what we call the nuclide, okay, you put it like this. Now, whenever we have this spontaneous radiation coming out from the atom, meron tayong tinatawag na radiation. Spontaneous emission of energy from the atom. Okay? And if we're going to look at this, alin ba yung nag-emit ng radiation? Usually sila yung tinatawag nating anong type ng isotope? Unstable isotope. So be careful kasi nahuli ko kayo sa isang question sa quiz. Okay? All of you got it wrong because of the word game that I played. So unstable isotopes, usually what happened to them is they disintegrate, spontaneously emitting radioactive particles as they transform into more stable form. Now, ano yung tinatawag nating subatomic particles? Okay? Yung mga radioactive particles na na-emit. So maybe, okay, i-include ko lang dito lahat ng subatomic particles, and then we will go on the one that we could say are radioactive particles. Okay? So we have the proton. And if we're going to look at the proton, okay, it has an atomic number or mass number equals to 1 and atomic number equals to 1. And classic example of the proton is the hydrogen atom. Sa neutron naman, okay, it has no atomic number, but it has a mass number equals to 1. So yan yung dalawa na nasa nucleus. When you call them together, that's the nucleons. Okay? Now, we have this so-called electron. Okay? And in this electron, meron tayong tinatawag na beta particle. Now, there's another name for this one based on the sign of your atomic number. So here you could see the sign of the beta particle is plus. So you call it positron. So ano kaya yung pwedeng other name ng electron na merong negative sign? Anyone? Katunog nung ano sa transformer character. Okay. So yung tinatawag na negatron. Okay, maybe this is the first time for you to hear this, but what do you think is the root word for this positron? If you're going to look at this, beta, if your beta particle is a positive electron, tawag sa kanya positron. But if your beta particle is the typical electron, okay, ang tawag sa kanya ay yung tinatawag na negatron. And if you're going to look at the reactions, so usually when you have this so-called beta decay, one of the product that's formed is a negatron. So let's say you have your lead, 82 and 214. Okay. If it's going to disintegrate, it can form a bismuth that is what we call equals to 83. So to balance both the atomic number and the mass number, so kailangan mo ng subatomic particle that has a 0 mass number kasi pareho na yung mass number nilang 214 on both sides, and 1 that is negative because the atomic number here is 83 and the atomic number there is 82. And the subatomic particle that you have there is the beta particle. Okay, so to be specific about the beta particle, meron siyang tinatawag na positron kapag positively charged or positive yung atomic number, meron siyang electron or yung negatron kapag tinatawag nating negatively charged. And then another thing, that is radioactive, so ito yung tinatawag natin beta particle, is the so-called alpha particle. Okay, and I think this is some of the most important types of radioactive particle, yung alpha particle, okay, beta particle, ano pa nawala dito? What are the other radioactive particles, yung nag-ano kay Incredible Hulk? Okay, so that is, we could say, the gamma rays. Okay, and in some instance, meron ka rin pwedeng ano doon tinatawag na X-rays. So yan lang yung involved dito sa radiochemistry. I just need to, what we could show you the different decays that happen. Okay, because ito part yan yung tinatawag nating objective. Describe the different types of radioactive decay. Okay, now if we're going to look at the kinetics here, ano yung order ng reaction kapag, let's say, yung radioisotopes nagdi-decay, ano yung order ng reaction niya? Anyone? You still remember the zero, first and second order? So ano usually yung order ng decay or rate of decay? If ever I ask it in the finals, either multiple choice or true or false. So if you have a radioactive decay, that is what? Still remember that? Ano yung order of reaction nung tinatawag nating radioactive decay? Hindi niyo na maalala yung kinetics niyo sa Gen Chem? Okay? So, all radioactive decay undergo the so-called first order kinetics. Okay? So if you're going to look at this, what we call first order, maybe ilalagay natin A is equals to dN over dt, that is negative, and we could say the activity times N. So A, we could say that is the isotope's activity. Tapos ito yung tinatawag nating N, yung number of radioactive atoms present at time t. Okay? And ano naman tong lambda dito? What is that? That is your decay constant. Kapag kinetics yung inaano natin, yan yung tinatawag na rate constant. So we can rewrite it in what form? NT is equals to initial N E raised to the negative KT. Okay? And if you're going to look at the half-life, ano yung half-life natin dito? Ano bang half-life ng first order? So usually we have the 0.693 over K, di ba? But if it's a radioactive decay, it's 0.693 over alpha. Now, what can you say about the half-life with regards to the number of the radioactive atoms? May relationship ba yung T1 half doon sa N? Anyone? Class? May relation ba to dito sa NT? Is it dependent on NT? If you're going to look at the equation, wala kang nakikitang N dito. So that means it's independent, okay, on the number of the radioatom. It would remain constant throughout the decay process. So pag sinabi niyang 50% ng radioactive atom mo remain after 1 half-life, then 25% remain after 2 half-lives, and then 12.5. Ang tanong nga nauubos ba yung radioactive material after several half-life? What is your answer to that? Will the radioactive materials go to zero after a lot of half-life? Or you could say after a million half-life, the concentration of the radioactive atom is zero. Is that true or false? The answer is false. Because yung magiging new concentration niya is just 1/2 nung initial na concentration niya after half-life. Okay? Since lagi lang siyang nakakalahati. So hindi siya aabot ng zero. He's just approaching zero, but it never touch zero. So try to remember this what we call concept. Kasi it was tackled on Chem, but this is the principle that they use dito sa tinatawag nating radiochemical method. Okay? And if we're going to look at these radiochemical methods of analysis, usually it depends on what we call the specific properties. Okay? Specific properties. And if you're going to look at these properties, it has something to do with what? The type and energy of the emitted radiation. Okay? And then yung half-life, tsaka yung ano man yung decay schemes niya. So anong ibig sabihin yan? Beta decay, alpha decay, or gamma radiation. So depende doon yung radiochemical methods of analysis. Now the good thing about these methods, okay, they are both sensitive and specific. Okay? And usually, radiochemical methods are characterized by good accuracy and their ability to be adapted to a wider number of applications. So you'll be surprised that it's really what we call useful. Okay? And usually they minimize or even eliminate the need for separations that you usually use for other or in other, we could say, analytical methods. Okay? Now, before we proceed on this method, we look at the detectors or yung tinatawag na instrumentation, because this is the one that they use to determine yung methods na yon. Okay? So, another thing that we could say is medyo labor intensive to at what we call generate ng liquid waste kapag meron kang separation. Okay? And the detection limits tend to be high, especially doon sa mahaba yung half-life, yung isotopes. Okay? But if you're going to look at the instrumentation, usually, ito yung commonly used, yung tinatawag na gas field detector, scintillation counters, and semiconductor detectors. Now, fortunately for me, I was able to use these two. And I'm not sure if Ma'am Vicky was able to use also, because I used them when I was in University at Bacolod. Okay? So yung gas field detector, yan yung classic na tinatawag nating Geiger Counter. Okay? So we have license to do radiochemical activity in the lab. The requirements that we have there by the safety officer or the safety office of the university is to make sure to have a monthly inventory of our radioactive material compound. So every year, isa sa amin, nag-i-inspect doon sa radioactive area. Okay, kung merong mga spill, okay, tapos kailangan namin i-report. So this Geiger counter, if you're going to look at this, it just consists of a tube that contains an inert gas. Okay, so in this case, you can have what we call an argon. So what happened when the radioactive particle enters the tube, it ionizes the inert gas, producing an argon plus electron ion pair. Okay, and the movement of the electron toward the anode and of the argon plus toward the cathode generates a measurable electrical current. So usually ganito yung itsura niya, at yung ginamit kong Geiger counter doon sa lab is kagaya nito. Okay, parang feeling ko nga nun Ghostbuster, naghahanap kami ng radioactive chemicals. So other one would look like this. So as you could see, ano pa siya, analog pa, but most of the Geiger counter at present are already digital. Okay, we didn't purchase it. It's the safety office of the university who provided us this Geiger counter. So whenever we do any radioactive base or activity that involves radioactive chemicals, we have to make sure that after we do the activity or the experiment, that we didn't spill any radioactive material. SOP yun kapag gumagawa kami. So pag wala kaming ginagawa, all we need to do is do the lab safety inspection monthly. Okay? So yun yung isang way na nadidetermine kung meron kang radioactive material. Usually tumutunog eh. Kapag madami yung tunog niya, yung talagang hindi siya titigil eh. Kapag konti lang yung parang pag ano na so parang malalaman namin saan merong radioactive material. Okay? Now the second one, which I really have hands-on using, is the so-called scintillation counter. So if you're going to look at this, it's a big instrument. Pero ang ano lang dyan, yung maliit lang yung talagang nagmo-monitor dyan. May nilalagay ka lang dyan mga vials that you mix with fluorescent material. So you use a fluorescent material to convert the radioactive particles into easy to measure photons. Okay. Now, one solid state scintillation counter that they use is the one that contains a sodium iodide crystal that contains 0.2, okay, TII, which produces several thousands of photons for each radioactive particle. And the principle that we have here is the emission of the so-called beta particles. Okay, and the experience that I use is tritium. I use a tritium labeled antibiotics to monitor what happened to the antibiotics as it goes to the environment. Tapos yung isang antibiotics ko is a C14. I think I use tritium tetracycline and C14 sulfamethoxine. So the way that it doing the principles, the low penetrative power of beta radiation, the detection efficiency of the beta emitter, especially the low energy beta emitters, they're quite low. But what happened, okay, kapag meron ka ng LSC, tumataas yung ano nila. So the quantitation of beta emitting isotope is quite difficult without the liquid scintillation counter. So what it do, okay, is the sample is dissolved in the scintillation solution, yung tawag namin scintillant. And by the counting the photons produced in the reaction of the beta particles with the scintillator, the quantitation of the beta emitting isotopes can be easily carried out. So parang nagkaano lang kami nung count, radioactive count. Okay, kita nyo yan, ito lang yung lumalabas. So makikita namin yung difference doon sa sample namin. Okay. And ma'am, meron ba tayo nito sa LB? Scintillation counter. I know.
Dati
PN
kasi, kasi may subject kaming radiochem dati eh. Pero lumang-luma na yun, siguro mga 1970s pa.
Pero ganito pa rin yung ano niya eh, yung kahit yan
Yung
parang
kulay
nalulumaan. Liquid pa kulay yellow, yung liquid.
ayun, yun ata yung meron tayo, parang yun na i-imagine ko, hindi ko na matandaan na ginamit natin doon sa radiochem na klase eh.
Kasi ang ano niya, napakasimple nung technology niya. Sabi mo low-tech, but at least that's I think the still one of the most useful way to determine yung amount ng radioactive material. Natatakot lang ako noon. Meron kasi sa 6th floor din po ma'am na I don't know if you know the radioactive room there. Sa kabilang dulo ng lab ni Doc Aga.
Sa 6th floor sa ano, okay, sa UB.
Basta may gumamit doon ng gamma emitter. Sabi ko hindi ko muna gagamit, hindi ako papasok because I think another one they use phosphorus and phosphorus
P32.
So, gamma sabi ko nga doon sa isang kabatch ko, Mike, if you're going to use the gamma, the what we call phosphorus, let me know. Kasi hindi ako magsisipot doon sa lab kapag yun yung ginamit niya. Because mas penetrating kasi yung gamma kaysa doon sa beta.
Oo.
So you don't want to get exposed. And we use is what we call scintillation counters. Okay. So since we're dealing with antibiotics, so we try what I do is I try to mix my tetracycline with manure, all the shitty samples that we have. Sorry sa mga nakain. Because we try to monitor ano yung nangyayari. And in addition to that, we also have this detector doon sa chromatography because we try to see yung parang, okay, at this time, mataas yung count niya. So, ko-collect namin yung sample and we try to look at the structure. Yan yung way na nalaman yung tinatawag na, I'm not sure, you're familiar with the Krebs cycle? So what Krebs do is, he just use radio labeled. Okay, kung ano man yung compound doon. So at every cycle, di ba, nagpapalit siya. So he's monitoring kung ano nangyayari doon sa radio labeled isotope na na compound. So that using that thing, they were able to determine the structure doon sa Krebs cycle. So it's really an old technology. Okay. Now the other one, I have not used this, and I never seen this in real life. Yung tinatawag nating semiconductor detector, and this is a germanium detector. So it's the absorption of a single radioactive particle that promotes thousands of electrons to the semiconductor's conduction band, increasing conductivity. Now, lahat ito yung kailangan mo doon sa method na i-discuss ko. Okay? And I think I have some what we call simple problem here in addition to the one that we have. So meron tayong tinatawag na radiometric analysis, isotope dilution, at yung tinatawag na activation analysis. Okay? So itong radiometric analysis, ang ano dyan, yun yung direct analysis of a radioactive isotope by measuring its rate of disintegration. Okay? So this is the use of a radioactive reagent of known activity to isolate the analyte from other components of the sample. And the way that they look here, the activity of the product is directly proportional to the amount of the analyte. So parang ano lang to, yung kinetics, yung rate, okay, of kinetics na minention natin. So it's just determining how much was left after a given time. So ibig sabihin, you just need to know yung parang decay rate. And from our previous discussion, we could say we can end up with this. And is just equals to whatever is the activity times the half-life over 0.693. Okay, and I have an example here. So the activity in a 10 ml sample of wastewater that contains strontium 90 is 9.07 times 10 to the 6 disintegration per second. So what is the molar concentration of strontium 90 in the sample given the half-life for strontium 90 as 28.1? So try nyo nga anuhin, may kukunin na ako. Naiwan ko yung notes ko sa printer. Try nyo i-solve. Try to solve using the formula that I gave you earlier. So the formula was N activity times the half-life over 0.693. So ano yung mga ano ito? Disintegration per second. And then you have 28.1 year, which you're going to convert to what? So you need to convert 28.1 year to seconds. Okay? So kapag inano mo yan, 28.1. So ito yung mahabang ano. In 1 year, you have 12 months. In 1 month, you have 30 days. And then in 1 day, you have 24 hours. And then pwede natin siguro ilagay 1 hour is 3,600 seconds. Tama ba? So kung ano yung equivalent dito, palitan doon, and then you just have it as 0.693. Pero hindi pa yun yung final answer because the one that's being asked is, what's the molar concentration? So usually kapag nag-disintegrate yan, magpo-form naman siya ng ano atoms. So from the atoms, we're going to determine the moles. Tapos meron tayong given volume dito. So ano yung initial sagot dito? Anyone? 1.14 times 10 to the 16. So that could be atoms of your strontium 90. And then you're going to convert that. So from 1.14 times 10 to the 16 atoms. So ano yung conversion factor natin? In 1 mole, you have the Avogadro's number, 6.022. So you could see there's a mole there. So you have to convert this to liter. So makukuha mo. Ayan. strontium 90. So ano nakukuha nyo? (1.90 times 10 to the negative 6). So ito yung pinaka-common na analysis na ginagawa nila. So very important dito you know the half-life ng material na tinitingnan mo. Okay? And I think there's also an example there doon sa study guide natin. There's a link, a similar problem to this one. So question sa radiometric analysis. Before we go with the other one, yung tinatawag na isotopic dilution. Okay. So this is a widely used quantitative analytical technique of considerable value in complex mixtures of compounds in organic synthesis, biochemical system, and for the determination of inorganic elements in geological and biological samples. And it was first introduced by George de Boon Hevesi and R. Hobby or Hopper here. Okay, although there were more innovations done later on. Okay. Now the way that it involves the preparation of the analyte in the radioactive form, and I think I put some way of how this isotopic dilution is done. Okay, so here you have a small amount of your radio tracer of known specific gravity that's added to the solution of complex mixture containing an unknown quantity of same compound. Now the solution is warmed to make sure of the isotopic exchange. So ang ano dito, isotopes. Pero yung isang isotopes mo ay radioactive. Okay? And then what it do, it has this organic solvent containing a suitable reagent that's being added. And then you evaporated it to dryness. And then from the specific activity using this formula, the unknown weight is calculated as this one. Mass is just equals to the specific activity, okay, times 1 times the mass. Oh wait, not there. Dito muna tayo. So 1, 2, so two-phase aqueous solvent tracer mixture is stirred and radio tracer is quantitatively extracted, and then the aliquot of the organic phase is withdrawn on a planchet, and then you evaporate it to dryness. So once you evaporate it to dryness, as you could see, meron kang ano dito, okay, counter, yung Geiger Counter. Ang full name kasi yung Geiger Counter. Okay? And then you're going to weight the planchet, and then from that you determine the specific activity. If I'm not mistaken, kung tama ako ma'am, di ba yung naging issue yung suka sa Pilipinas?
Oo, kasi may adulteration yun eh.
Baka ito ata ginamit nilang technique doon.
Oo, sa carbon-13. Kasi nga, ang problema, yung mga suka natin, acetic acid na nilalagyan na lang ng, synthetic acetic acid na nilalagyan na ng cloudifier para maging turbid. So in other words, kung talagang malalaman natin na natural yon, which is from coconut, from sugar cane. Oo, so yan yung ginamit na study. Ayan yung ginamit na technique. Actually, it was the PNRI, Philippine Nuclear Research Institute, kasi nga radioactive carbon-13, para malaman nila yung adulteration due to the synthetic acetic acid compared to sa natural na coming from coconut and sugar cane.
Naging issue yun dyan eh. But
Kasi nga
I'm
syempre
just,
kung ano ka, kung gagamit ka ng synthetic acetic acid, edi parang yung tiyan mo kinalay kayo ng acid. Samantalang at least yung sa
natural.
natural, oo, mas tame, mas tamer, kumbaga. Tsaka yung natural acetic acid, hindi yung synthetic. With, of course, with the other organic acids na kailangan natin. For example, yung citric, kailangan natin yan. Tsaka yung malic, and then the lactic. So aside from yung pure acetic acid na synthetic, kailangan pa rin natin ng ibang organic acid sa metabolism.
Yeah.
Kaya yung Philippine Nuclear Research Institute of the Department of Science and Technology yung nag-search on the adulteration of the acetic acid, commercial acetic acid.
Yeah, one of my BFF is based there.
Okay.
Sergio Caris.
Ganun ba? Oo.
Best friend ko, kumpare.
Sa PNRI?
Sa PNRI. So yung kaya ako naging dyan, yung nag-ano sa research dahil sa influence niya.
Okay.
So that's why I'm familiar with this one. I'm just showing you that we do that. We do this thing there in the Philippines. We have the facilities, yung PNRI, if ever you end up working on that facilities. Okay? Because gusto ko i-relate na, yung ginagawa natin dito, yung minimension natin dito, it was also done there. So yun nga yung naging issue yun. I think even Dr. Dairit and Ma'am Flerido, or,
si Bubut.
Si Ma'am Bubut. Sila yung nasa front line.
Oo.
So the technique that the chemists from PNRI use is by isotopic dilution to determine yung, so parang minix nga lang niya yung C13 doon sa natural na. Okay? And the way that you do this isotope dilution, so usually yung principle kasi dito, yung specific gravity, okay, nung mixture, nung stable, tsaka yung radioisotope na it remains unchanged during the chemical processing. Kasi ang nangyari dyan is merong isotopic exchange, nag-exchange sila. Okay? So accurately known amount of the specific activity nung radiotracer is added to an aliquot of analyte mixture containing these salt components. So after you add, okay, after the addition, the resultant specific gravity decreases. And the chemical separation procedure is carried out where the component need not be recovered quantitatively, but it must be in chemically pure forms with well-defined composition and insufficient amount so that it can be weighed. So ang nangyari nga dito, yung calculations na nangyayari sa isotopic dilution. So parang meron kang activity ng isolated na compound. Okay? So I think I can express it like A of A. So ito, kapag na-recover mo yan, both the radioactive tracer tsaka yung non-radioactive analyte, so usually A and A of T is what we call equal, and the WX is just WA minus WT, but usually you fail to recover all of the analyte, and in this case yung A of A mo, okay, is less than A of T. So ang nangyari, yung ratio ng weight na ano mo dito sa equation na to, okay, it accounts for any loss of the activity that results from or failure to recover all the analyte. And if you solve this equation here, lalabas itong equation na to. And usually ito yung ginagamit nila. And I have a sample thing here. Okay. So ang ano nga dito, makakala nyo high-tech, pero siguro if there's a software that is interface, it's automatically gives you the value. But if it's not, mano-mano mong gagawin niya. Ganun ang ginagawa ko noon sa LSC. So ang lalabas yun yung computer paper pa, yung merong butas sa tabi. And then kukunin ko yung ang dami, tapos the date ko, kasi minsan hindi tama yung date doon, tapos titingnan, ito yung sample ko, ito yung sample ko. So ganun. And they usually use this for biological sample, okay, organic synthesis, okay, at yung inorganic element. And I have an example here. So when they look at the concentration of insulin in a production bat determined by the isotope dilution. So you have 1 milligram of sample insulin that's labeled with C14, and it has an activity of 5.49 counts per minute. So it's added to a 10 ml sample taken from the production bat. And after homogenizing the sample, a portion of the insulin is separated and purified, yielding 18.3 milligram of pure insulin. And the activity of the isolated insulin is now measured at 148 count per minute. So how many milligram of insulin are in the original sample? So ang aanuin mo lang dito, yung gagamitin mo lang itong nandito. I mean the whole thing here. So Wx equals to A of T over A of A times WA minus WT. So ano yung mga value? Saan natin i-assign yung mga value na given dito? Where do we assign 549? So ang sabi ko nga sa iyo, yung A of A is always less than A of T. Okay? A of A is the isolated sample. And yung isolated sample mo ito na merong 148. So we could say this is what? 549 CPM over 148 CPM. Oops. And then the WA would be the mass. So alin yan? Yung, nasaan na ba yun? Yung 18.3 o yung 1? So we could say the WA there, that's the 18.3. Tapos yung WT natin ay yung 1. So ano ngayon yung Wx? Yun yung mass or weight ng original sample. Ano nakuha niyo? 66.9 milligram. So this could be old school, or yung kung bago na yung instrument, usually may pre-installed software that will tell you. I-input mo lang yung mass, okay? Siya na magse-set ng reading, and it will give you or generate to you the amount that you are looking for. And this is commonly used. One of the radiochemical methods that has a wide range of application. Now, the last one ay yung tinatawag nating neutron activation analysis. Okay? So, there's only few analytes that we could say are naturally radioactive. Now, itong method na to, ang tawag talaga dito is activation analysis. Okay? And here, if you have what we call neutron, so ibig sabihin neutron ang nag-i-induce ng nuclear reaction. Kasi mayroon pang ibang subatomic particle that can induce the nuclear reaction, the photons, charged particles, okay, at iba pang subatomic particle. So this was discovered in 1939, okay, when Hebesy and Libby found that samples containing rare earth elements became highly radioactive after exposure. So as you could say, si Hebesy na naman. So I think wala siyang ginawa kundi look at this what we call radioactive based methods. So they found that samples containing certain rare earth elements become highly radioactive after exposure to a source of neutrons. So from this observation, they recognize the potential of employing nuclear reactions of samples followed by measurement of the induced radioactivity to facilitate both quality and quantitative identification of the elements in the sample. So if you're going to look at the principle here, okay, yung technique ng neutron activation analysis, so you could see you have here neutron responsible for the activation of the reaction. So we could say two steps yan eh. One is the so-called irradiation, okay? And since you have neutron here, you could say you irradiation of your sample with neutrons, and then the subsequent measurements of the induced radioactivity. So parang niradiate mo siya, tapos i-measure mo yung radioactivity na na-generate. Okay? So, based on that, they will be able to find kung ano yung radionuclide na yun. Kasi most of the radionuclide, they are characterized by their what? Okay? Yung gamma energy, tsaka yung tinatawag na half-life. So that's the way that they did this neutron activation analysis, and this is we could say still useful until today. Okay, so ang ginagawa nila nga dito, for example, if you place a sample that contains non-radioactive aluminum, aluminum 27 in a nuclear reactor, and irradiate it with neutrons, ang mangyayari, okay, so that's aluminum 27. So aluminum would have 13. So kapag meron kang na-induce dyan na neutron, it would give you aluminum 28, 13. And this is, we could say, radioactive. So meron yung characteristic na decay process that includes the release of this what we call beta particles. So mag-disintegrate yan further to give you what? 28 aluminum, and we could say 13 plus 0 negative, no, aluminum 14, not okay, and gamma. So ito yung minomonitor nilang radioactivity na marirelease. And the way that they do is they monitor with time, okay, after irradiation, and then relate it doon sa concentration, okay? And the use of this neutron, we could say activation analysis to determine the presence of a variety of elements in the sample, like the mercury levels in tuna fish, aluminum levels in fingernails, gold levels in hair, kung meron man kayong gold, okay, zinc levels in soil, tsaka yung arsenic levels in plant. So meron na silang na-develop na tinatawag na radiochemical method based on this. And in fact, EPA has some standard methods to analyze, let's say, environmental samples containing some elements. Some prefer this, especially kung meron kayong capability. And I know PNRI has this because they have a lot of division there. Okay. So meron silang tinatawag na lahat yung irradiating machine to generate radioactivity. So sample thing that they use is maybe this one, the concentration of manganese in steel. So usually in an analytical chemistry lab or instrumental analysis lab, we determine manganese in steel using AAS and UBBs. But in addition to that, you can still use this so-called radiochemical method. Okay. Sa AAS, you usually dissolve your steel in nitric acid. And then if it's not colored, you can do AAS. If you want to generate colored, so maybe you convert your manganese to permanganate, which is colored, and then you can look at the absorbance. Okay. But another way to look at this is using radiochemical method, like the neuron activation analysis. And they use the method of external standard. So what they have here, you have 1 gram of the sample of an unknown steel, and then a 0.950 grams of the standard steel known to contain 0.463% weight by weight manganese, and you irradiate it with neutrons for 10 hours in a nuclear reactor. And then after 40-minute delay, the gamma ray emission gives 2,542 counts per minute for the unknown, and 1,984 counts per minute for the external standard. So what is the percentage manganese in the unknown steel sample? So yung formula na pwede mong gamitin dito, so usually initially you have like the activity, okay, with the given K. We could say that's the sample, and then K, WX, and then AO, the standard, and then you have KWS. And when you combine them, ano yung makukuha mo? Okay. WX equals to A of X over A of S times WS. So X is the unknown that you have. S is the standard, the external standard that you have. So all you need to do is place the information that you have there. So 25421984. So paano natin gagamitin yan? Maybe before we do that, we go first with the weight, right? So the WX mo, ang weight niya ay 0.463 per gram ng steel. And then you multiply it, ilan grams yung steel natin overall. Standard steel. Okay? So you have 0.950. And then from that, ito yung gagamitin natin dito. And then we replace this one with whatever reading. So we could say 2542. And the external standard is 1984. And then this one, so ilang grams yung manganese na meron? Ano yung sagot, class? So you have 5.64 times 10 to the -3. Now, did it answer a question? It just answer how much of manganese do we have in the sample. Okay? So to get the percentage, so ilan yung grams mo ng sample? 1 grams, di ba? So that means you have 0.564% na manganese. Now, anong advantage dito? Let's say compare sa AAS and UVBs. Anyone? Let's say kung meron kang facility na pwede mag-analyze ng ganito, anong advantage na doon sa AAS tsaka sa UVBs method? I'm not sure if I discussed you the term yung tinatawag na destructive at saka non-destructive method. So the main advantage of this one is this is a non-destructive method. Okay? So when we say non-destructive method, you can recover the sample. Compare sa AAS tsaka sa UVBs, yung still mo destroyed na. Hindi mo na siya marirecover. But in a neutron activation analysis, this is a non-destructive method, so marirecover mo yung sample. And the good thing with this one, this is applicable in all elements in the periodic table. And usually ito yung ginagamit nila, anong field sa tingin nyo? Sa forensic science, sa archaeology, tsaka sa art. Kasi di ba yan yung mga artifacts na as much as possible hindi pwedeng masira kapag ina-analyze mo. You want it to be intact. Okay? So, this is, we could say, a very useful method. Itong, lalo na yung dalawa, yung neutron activation analysis and yung tinatawag na isotope dilution. So, question. Kasi tapos na tayo sa radiochemical method. Na itong particle size, napaka-easy lang yung nilagay ko. There are a lot of what we call particle size analysis, but I just narrow it down doon sa study guide natin. Okay? Because if you're going to look at this particle size analysis, even the microscopy, yung TEM as SCM, kasama doon. But we just focus on what we call the one that is listed there in the study guide that we have. Now, the basic question, if you do this particle size analysis, is the question, what is a particle? Because if we're going to look at the definition at basic level, we can define particle as being a discrete subportions of a substance. Okay, so for simplicity, we can say we're just going to tackle about the so-called solid particle. Okay, and they said particle size analysis is really what we call important. Ang tanong nga is, why do we measure these particle properties? So, dalawa daw yung rason. One is better control of product quality. And if you're able to do that, you can deliver real economic benefits. Ano yung mga benefits nito? Ability to change a higher premium for your product, reduce the customer rejection rates and loss order, demonstrate compliance in regulated markets. Okay, and the second one is the better understanding of products, ingredients, and processes. So marami siyang application. Okay? So when you be able to better understand the products, the ingredients, and the processes, you can improve the performance of your product. You can also troubleshoot the manufacturing and supply issues. You can optimize the efficiency of the manufacturing processes, and then you can increase the output or improve yield. So magiging ahead ka doon sa competitions. But the thing is, ang dami mong particle properties na dapat i-measure. Okay? And if you're going to look at the measured rate, the dimension of the industrial particles, you can look at like this one. From 10 to the negative 2, from millimeter to nanometer. And these are the different samples that you have there. Yung virus na problem natin is almost in nanometer range. Okay? Now, if you're going to look at the method that measure the particle size, so ito yung ginagamit nila. Okay? So in the nanometer range, you have this dynamic light scattering, and at longer range, you have the so-called laser diffraction. And in fact, ito lang yung pag-uusapan natin ngayon. But there's still a lot. Sedimentation would be what we call the same size as the laser diffraction, although the range of laser diffraction is much wider compared to the sedimentation. So yung sieving, are you familiar with sieving? Ito lang yung nagsasala kayo. Okay? So it would be at a much higher, we could say, longer particle size. And then if you're going to look at the particle characterization needed, okay? So if you look at the size, so these are the techniques. So you see the laser diffraction, dynamic light scattering, and then the sedimentation. If you want to look at the shape, that's the automated imaging. If you want to look at the zeta potential, that's electrophoretic light scattering. If you want a dynamic range, so the more dots that you have there, the better. Okay. Now, if you want in terms of rapid, so we could say the laser diffraction, dynamic light scattering are both rapid. Yung sedimentation, masyadong mabagal. Resolution, the best is automated imaging and electroson sensing. Sampling, the laser diffraction is better. And then for wet or dry sample, so you could see laser diffraction is more practical compared to DLS. Okay. Now, my request to you is look at the video that you have there, because what I have here is just like a summary kung ano yung ginagawa nila. So if we're going to look at the comparison, so dynamic light scattering can go on shorter particle size compared to the laser diffraction. So if you're going to look at the laser diffraction here, yung particle sizing niya, it's a widely used particle sizing technique for materials ranging from hundreds of nanometers to what we call several millimeters in size. Now, the main reasons for the success of the laser diffraction, as shown there in the table, it has a wide dynamic range. Okay. It can go from submicron to millimeter size range. It has a rapid measurement. You can get the results in less than a minute. Okay, it is repeatable. Large number of particles are sampled in each measurement. Instant feedback. It monitor and control the particle dispersion process. And then high sample throughput. So you can have a lot of measurements per day. Parang micro titer well plate. Okay, you don't need to calibrate it, and it has a well-established technique covered by ISO 1000 or 13320. Okay, so the way that the laser diffraction would work, it measures the particle size distribution by measuring the angular variation in intensity of light scattered as laser beam passes through a dispersed particulate sample. So ang nangyayari doon, yung mga larger particle nag-i-scatter ng light at smaller angle relative to the laser beam, and the smaller particles would scatter light at larger angles. Okay, but I think I want you to look at the what we call the source or the material that was posted. The link is in the study guide. And I think it's Sir Franco who prepared that material. Now, the other one that we have is the dynamic light scattering. Ang tinatawag nating DLS. So it's sometimes referred to as photon correlation spectroscopy or quasi-electric light scattering. It's a non-invasive, well-established technique for measuring the size of particles and macromolecules, typically in the submicron region down to below 1 nanometer. I'm supposed to use this instrument before the pandemic hit. Okay, so by the time it arrived in my other lab, the York College, the pandemic hit. So hanggang ngayon hindi pa nagagamit yung bagong instrument. Because I try to use the nanomaterial samples that I have that interact with the protein. So we see some binding. So we want to look at the size of the nanomaterials when it is bound to the protein. Okay, so it can be used to measure sample which consists of particles suspended in a liquid, like proteins, polymers, micelles, carbohydrate nanoparticles, colloidal dispersion, and emulsions. I'm not sure if Dr. Peralta has this, because I think he had a nano lab. And if you have a nano lab, if you want to characterize your nano, you should have a DLS instrument. That's a must here. Meron kaya, ma'am?
Meron siya.
Meron siya?
Kasi service lab yung nanotechnology lab ni Dr. Peralta. So meron siyang iba-ibang klase. So the DLS, synthesizer. Oo. Meron siyang yung BHT pa yun for pore size and pore volume ng mga nanomaterials. Kaya lang ang problema is may charges. Even for students ata, merong charges, service charge, pero medyo mahal. Ngayon nakabili ako ng Horiba synthesizer for
synthesizer po, okay din yun.
So pag pumunta ka dito, Meng, maraming magagawa. And sana nga itong mga batang ito, kung talagang mag face-to-face na and pwede na kayong mag-laboratory, sana nga maka-thesis kayo para at least makakita naman kayo or makahawak naman kayo ng DLS. So if you want to work on, kasi ginagamit ko doon sa biochar project ko. So
mag-perform ng nanomaterial yun.
Oo, ng nanomaterial. So itong mga batang to na sana.
Yan yung in ngayon, students. Pag nano ka, sabi ko ba't hindi na ako nag-nano?
Pero you still have chances kasi nasa peak ka pa ng profession mo. Ako nasa na ako, stationary phase. Kaya gusto ko na lang.
Minumog na nila ako sa admin eh.
Ay, naku, mahirap. Hindi ka makaka-publish pag gano'n.
Yun na nga ako eh. Kaya Buti nga hindi ako nanalo sa paas eh. Kasi sakit na ulo ko, sir.
Mahirap
Eh,
kaya kumuha ng admin pagka eh. Yung mga admin mo, pagka mga 55, 60 ka. Pero
Kasi
ngayong mga,
required ho sa promotion eh.
oo nga eh, oo.
Sinabihan na ako, you'll never get to full professor unless you're going to at least be
Admin,
a
ano?
program director. So, yun yung minimum eh. Program. Sabi ko, at least it's just program director, not chair. Kaya
Oo.
sabi ko, I don't have any ambition to be a chair.
Oo.
Hmm.
Tapos yung mga estudyante ko dati, nung face-to-face pa, kasi meron akong connection sa Nanotechnology Analytical Services Lab. Meron dito sa Philippines eh.
No.
Pinapasyal ko yung mga estudyante ko doon para makakita sila ng electron microscope, para makakita sila yung mga DLS, atomic force microscope.
AFM, yun. Yun yung required.
So si Dr. Peralta, meron siyang AFM. Okay.
Meron
So
siya?
meron siyang AFM. Oo. Meron siya. Kaya lang nga, siguro mahal.
Mahal
And then sa
yun
electron microscopes to children, meron kayo scanning electron microscope, yun yung SEM. So yung topography lang ng surface. And meron kayong transmission electron microscope. Ito yung talagang electrons, pupunta siya doon sa inner core ng mga samples. Kaya sana nga with the face-to-face, okay sanang mai-tour sana itong mga bata.
Nano is maganda yung field niya. Kasi nga yung kahit nga kami
At saka,
nun.
if you will work on the mga mga semicon companies, for example, yung mga nagpo-produce ng yung mga spare parts ng mga cellphone, etc. Naku, yung mga semicon companies, ang daming microscope. Siguro in one company, mga 10 na electron microscopes. Kaya sana nga ma-familiarize kayo para pagpunta nyo sa field, kumbaga paglabas nyo, hindi kayo medyo probinsyano na ay nakakita na ako ng electron microscope. At saka dati kung makikita niyo electron microscope sa mga libro, mga floor type yan na malalaki.
Ngayon.
Pero ngayon, tabletop na siya. Ganon. Kaya huwag kayong magugulat pagka makakita kayo ng SEM or TEM na tabletop. Kasi yung mga nasa libro, yung mga lumang libro natin, siyempre.
Buong room.
buong room na parang ang laki-laking parang chest freezer.
Kasi ngayon sa York, yung TEM, sabi, bakit nasa basement yun? Ang laki kaya. Tapos yung nagpatulong sa akin, yung isang nano material nila, sa nanghingi ng support. So nag-ano siya ng SEM. So medyo maliit lang. So kasama nga doon yung DLS kasi meron talagang nagnanano. Kasi sabi required yan. Ang next na nakakuha din siya ng AFM eh. So meron siyang room doon na kasama yung SEM tsaka yung AFM. Sabi niya, kung gusto mo ituloy yung ginagawa. Kasi sabi ko, I just want to see what's the interaction is. Kasi bumababa yung absorbance, nagbabago yung CD, tapos yung fluorescence bumababa. Sabi namin, gusto ko malaman ano nangyayari. And class, this is sabi nga nila if you look at the number of papers published, nano yung number 1.
Correct.
The technique that they do is when they change the size of the material, its property also changes. Kaya yung parang naging popular yung field na to, yung tinatawag na nano.
Tsaka application niya sa food, sa medicine, sa environment. Name it. Sa agriculture, kasi may mga nano-fertilizers na eh. Nano-fertilizers, nano-pesticides. Kaya i-consider nyo yung yung field na nanotechnology. And sana nga pagka nag-face-to-face kayo and you're ready to do your thesis, you are always welcome. And siguro kung sa 137.1 tayo face-to-face na siguro I can offer na ipasyal kayo doon sa lab para makita nyo yung mga instruments for particle size analysis. And then, Beng, pagpunta mo dito, marami na akong gamit. Hindi na ako mahiya. Wala lang ako talaga nung CV, yun ang bibigpitin mo.
Dala ko naman po yung portable ni Al eh. And the last one that we have is this so-called photo sedimentation. So, sa tingin nyo, saan siya nagagamit? From the word itself. Anyone? Yung photo sedimentation. So, it usually used doon sa tinatawag nating sediments. Okay? So yun yung history nung tinatawag nating na photo set. Ang main word nga nito is just what we call sedimentation. Tapos nilagyan nila yung photo kasi ginawa nilang parang photometric measurements. Okay, so tinitingnan lang nila yung sedimentation speed ng particles. So parang nangyari, may dispersion ng samples na ini-examine nila and a liquid that we could call the dispersion medium is first prepared. And what they do is when they choose the so-called dispersants, they take into consideration that it has a lower density than the particles that it need to be examined. Bakit lower yung density? Para yung particles na ine-examine mo magsisink doon sa bottom during no sedimentation. Okay? And one thing also, yung particle mo dapat hindi mag-react doon sa dispersant. So the dispersant flows around them and then in a laminar manner. Tapos yung dispersion mo may stirred until it can be assumed that the particles are already homogeneously distributed. Okay, so if you're going to look at the slide, the photosedimentation is carried out with the aid of a photosedimentation device. And according to the description, there are devices in which the sedimentation takes place in centrifuge or those in which the sedimentation takes place only through gravity. So ito yung three main particle size distribution. But I have told you there's still a lot. Okay, kasama nga yung microscopy, sieving, okay? But we choose to do this one because especially this one, the dynamic light scattering, that's the one that is what we call the very useful at this time. And if you're going to look at the best materials about these methods, ang main source na masasabi ko ay manggagaling doon sa mga distributor or supplier ng material. So that ends our 137 synchronous session. Tamang-tama lang pala. Question, class. Yung 137.1 nila, ma'am, ngayon din or next sem pa?
Tinatapos muna yung yung 137 bago yung 137.1 kasi nung sa atin sabay yun di ba? Sabay yung 137 tsaka 137.1. Ngayon, inuuna talaga tong lecture and then yung 137.1 next semester kung papasa sila sa 137 lecture. So, ganon.
So, ibig sabihin, mas maraming section ng 137.1 next sem.
Yun ang sabi ni Ami. Kasi kinakamusta niya ako eh. Sabi niya, okay ba yung 137? Sabi ko, okay naman. Maayos naman yung mga...
Yeah, unless hindi kayo kumuha ng final exam. Mukhang papasa lahat. Pag hindi kayo sumipot, doon magkaka-I kayo.
Oo. So, sabi ko kay kasi tinitignan na niya yung mga section offering sa next sa second sem, second sem. Kasi nga ang 137.1 10 lang per lab section. So kung marami tayo ngayon, so sabi niya na kung marami tayong marami tayong section sa 137.1 next sem. Pero sana lahat kayo pumasa na. Children, ayusin niyo na yung mga problem set and hindi pa nga ako nakakapag-check pala. So but anyway, I hope na kahit semester break na, tapos ang classes, we can always text you in case na meron kayong mga deficiencies. And sana open din kayo na matextan ko kayo in case may mga kulang.
Yeah.
Hindi rin ako magbabakasyon. No?
Yeah, we will only disturb you if something is missing in your requirement. Ganun lang yung magiging ano natin sa Christmas break.
Kailan ba ang finals?
Wala pa daw ano nilalabas
schedule.
Pero fix naman daw yan eh. So dapat daw walang ano ano tawag doon? Yung parehong schedule, conflict.
Oo, conflict.
Kasi based naman daw sa time, pareho naman yung time natin. So I don't think may iba silang time na katulad nito. So once na maano yun yung gagamitin nating time. And it will be a long, I think, a 2-hour one. So ang maari, objective part, tapos yung ibang calculation, we will send it through Google Classroom. Tapos susulat nyo, then i-upload nyo. Or gusto nyo, multiple choice na lang para hindi na kami mahirapan. including yung including calculation. Ano?
Okay din yun. Calculations pero multiple choice.
Board exam, multiple choice naman, di ba?
Kasi ang hirap nga mag-check pagka...
Ano yun? All or nothing. Black or white. Walang problema sa akin yun. Naalala ko si Sir Ayo noon eh. Yung Gen Chem. Ginawa niya lahat multiple choice.
Finals.
Basta yung section, hindi yung section niya. Tapos pagdating ng finals, kasi departmental. So nag-a-adjust yung estudyante niya.
Oo nga.
Sabi niya, papahirapan ko sarili ko. Di mag-multiple choice sila.
Pero ang hirap gumawa ng multiple choice questions.
Ay, hindi.
Ang hirap.
May training na po ako kasi nagsusulat din po ako sa ACS exam.
Okay.
So ang warning ko sa
Grabe.
inyo, yung mga number na lalabas doon, yung choices doon, yun yung number na lalabas pag nagkamali kayo ng calculation. Kaya i-double check niyo.
Ganyan sa board exam dapat matrain sila na meron sila makakalculate na yun ang wrong answer.
Kasi ganun din yung training sa amin na gawin mo yung choice na yung common mistake sa calculation. So parang train sa amin yung as examiner. So kaya ang mga estudyante ko, first calculation nakita mo may katama doon sa choices mo, make sure you double check it. Kasi pag dinimes mo or dinivide mo, yung ano yung answer, isa sa mga choices na lalabas. So ganun lang din yung ano ko sa inyo, warning.
Minsan nga, sa board exam na-encounter namin to wala dun yung correct answer. Basta choose the best answer.
Yung closest.
Sabi ka talagang mga board of chemistry may oras para mag-calculate. Okay.
So tanong. Magpakita na kayo. Mag-ano na tayo. Last na natin to.
Merry Christmas, children. Open your cam.
Pamatay schedule natin pareho, class. So hopefully,
hindi naman sila pala natulog.
Available na yung quiz tsaka problems by tomorrow. But if ever, I will not be able to make it, pasensya na lang. May pa-exam din ako bukas eh. Tapos nagagawa kami ng final exam na departmental. So, aside
ako naman, nasa lab audit ako ngayon. For ISO 17025. So, ino-audit ko yung Dole Philippines sa South Cotabato, yung kanilang cannery.
So, and also, class, maghanap na kayo ng advisor nyo. Your third
In
year,
prep-
right? Mga third year ba kayo?
in preparation for the thesis.
Kasi minsan yung thesis yung nagpapatagal sa inyo. I'm proud to say, on time ako nag-graduate. Pero yung last semester ko, isa na lang yung course ko. I'm BS Ag Chem, so 5 years yun. But if you are a BS Chem, it's really what we call, kung talagang natapos mo siya on time, it's really isa ka sa mga loading. Because it always takes, lalo kaming na delay, lalo na pag organic. Pag nagsisynthesize kayo, and I don't think you can do that at this time. Yeah. Sa analytical kasi kung ano yung makita mo, yun na yun.
Oo nga.
Like what Dr. Baril said. Siya kasi yung teacher ko.
Oo nga. Siya rin siya ang teacher ko sa 137 tsaka 137.1. Okay. So,
Okay.
smile. So, wear your best smile na ha. Wear your Christmas Christmas smile. Ready? Okay, ready? 1, 2, 3. Isa pa. Ready? Smile. 1, 2, 3. Marunong ba kayong kumuha? Baka mali yun na. But meron nakalagay save to OneDrive. Ayun, screenshot save. Hanapin ko na lang. Okay, so
maraming salamat sa inyo. I hope you learned something, and to remember the basis doon sa grade nyo. I mean, yung learning nyo, hindi yung grade na makukuha nyo, kundi yung preparation nyo sa board exam.
correct.
I mean, you can get an A here, pagbagsak kayo sa board exam, talo pa rin kayo.
At saka yung preparation for work, yung future work ninyo.
And if
Okay.
ever you're going to need me in the near future, you know where to find me. You message me sa ano.
Ako din, nandito lang ako sa Laguna, sa UPLB. Okay, so tulog ka na, Meng. Anong oras na doon? 1:00 na madaling araw.
Hindi, 12:00 ho. Kasi
Kasi nga
nag-daylight kami. Kaya,
daylight savings.
Kaya pag yung late ng semester, lagi akong pagod. Kasi talagang umiksi yung ko, lalo na pag Wednesday. Ngayon, parang kami lahat stress kami lahat. Ang daming grade done. So, thank you very much, class. Okay. Ma'am,
bye-bye.
Pa kayo, ma'am?
Meron ba kayong mga sabihin? Wala? Thank you very much. You can always contact us if you have problems.
May tanong po ako sa yung mga nagkamali po ng dito, input ng email po sa quiz po.
Hindi nyo lang makukuha yung score. Kasi usually, kapag nag-release ako ng score, kung ano yung email nyo, doon siya pupunta. So pag nagkamali kayo, hindi nyo makukuha yung score. But the score will still be there. Hindi mo lang malalaman yung score mo doon sa quiz. But you can always email me and let me know anong quiz yun. Kasi I think andito ba si Yvette?
Thank you po, sir.
Nagano siya na, hindi ko po makita yung score ko. Sabi ko, may score naman siya. So usually kasi hindi sinasabi nung system kung mali yung email ad nyo. Kasi kung ano yung sinubmit nyo nung nag-quiz kayo, so once i-release ko yung score, babalik doon sa email ad na yun. So pag mali, hindi nyo na makukuha. Pero yung score nyo, it will remain the same. So all you need to do is ask me. Kasi nandoon naman yung yung Google form. It will always remain there. Okay. Ano pa yung question nyo? Lahat kayo nakakuha na kasi as of before our class, there's only 39. And then I think one was not able to get 5A kasi nag-brown out. So naabutan nung Kung hindi pa kayo nakakuha yung dalawa, I think it will end US time. Hindi yung tawag dito Philippine time. Pero tinatry kong iset na dyan. But I think it always like here. Kasi dito, kung dito ka nagsiset, yung time dito ang mag-aano. But don't bank of it kasi hindi mo alam, mawala ka ng internet especially during the final exam. Okay? So, ang final exam, if you want it multiple choice, siguro ang max na may bibigay namin is 2 hours. But within a time frame, hindi yung lahat kayo kukuha sa time na to. So, parang mag-open tayo ng alas 12 dyan, tapos hanggang midnight. I mean, before midnight the next day. Okay? Kasi mahirap yung lahat kayo, let's say 8 to 10, mamaya brown out dun sa province nyo. So, kawawa naman kayo. So, we will make it like a time frame. But don't work on the last minute. Kasi mga estudyante ko ganun eh. So, pag nag-down yung system, so, kakamot na ng ulo ko, mag-extend ko yung parang, I think last week, nag-down yung Amazon, apektado yung classes na namin. So lahat sila, we cannot use our lockdown responders. Tapos ako din, hindi rin ako makapasok sa system. So just don't do everything at the last minute. But once na naman yung schedule nyo, I think you always get my email, right? Sa sa Google Classroom. My Mirna Medillo.
Hindi pa ba nabibigyan ikaw ng tamang
Hindi ba?
Sinabi ko na kay Ami.
Si Mark sabi ni Mark, sino yun? Sabi ko, yun yung kinuha email ni Mikor. So, pag meron kayo yun, ako yun. Yung iba sa inyo, ma'am, ako yun. Nakikigamit na ako ng account kasi wala pa akong UP email account. Yun na nga, matatapos na yung appointment ko. December.
Sasabihin ko kay Ami, hindi na natin ma-invite si Meng kasi hindi niyo binibigyan ng tamang email.
Pero maano pa naman yun kasi at least may kasi pag wala akong UP account, hindi ako makakapasok sa Google Classroom. So, ang gumawa ng paraan nun si Sir Micor, I think he's a UPLB program employee. Hindi daw ginagamit yung email. O, so yun na. So, ako yun, okay?
Sa B program pala yun.
Kaya minsan may email doon about invitation sa B training.
Okay.
So, yun yung story doon. Baka isipin nyo, sino yun? Nakikigamit lang ako kasi wala pa rin akong email account. Okay, official email account. Nag-request na ako. Ang hinihingi sa akin ata yung official appointment. Di ba namatay yung mother ni Ate Mabs? So, ayaw ko.
na-delay?
Ayaw ko siyang disturbuhin.
Pero sige, sabi sa akin, kay Ami.
Nung friend ko sa sa HR, may appointment na daw ako. Sabi niya, hanggang December 30 ata appointment mo, Franz.
Sige, follow up ko kay Ami.
Sige, class. May tanong pa?
Okay, bye-bye.
Okay, bye. Good luck sa inyo. Alam ko, marami kayong ibang finals eh. Kaya nyo yan.
Bye-bye. Kaya yan, kinaya namin eh. Bye-bye. Bye, Meng. Thank you.
Sige po, ma'am.
Thank you po, sir.
Thank you po.
Thank you po. Bye po.
Thank you po.
Thank you po.